now we're going to move into section 10.2, where we're going to start talking more about triangles. So first, we should get a better sense of what a triangle is in the context of a closed geometric figure. So all we're doing when we look at a closed geometric figure is some shape that we form where we take a point and we draw some amount of lines, some amount of movement around it, and then end up back where we started, where there's nothing left around on the outside. And to do that with a triangle, we're making a shape where we have three sides. Triangle, we also have three angles. And one of the defining properties of triangles comes from something called Euclid's theorem. Now, we should think back for a second to stuff we did way back in chapter 1, where we talked about theorems in the context of deduction, where theorems were these results that we could show using deductive arguments. And the idea here is we're going to make a kind of argument to explain a very basic property of triangles, that the sum of their interior angles is 180 degrees. So first, let's say that we have two parallel lines, and on one of those lines we have some point. So we have a point on one of the lines, and we have another line parallel to it. And then what we're going to do is take those lines and that point and make a pair of transversals that meet at a vertex formed by that point. So we've got a whole bunch of things in there, but in between those two parallel lines and the two transversals, we will have formed a triangle. And what we can do with that triangle is pay close attention to some of the angle measures inside of that construction, where if you look at things like angle 2, 4, and 5, those have to add up to 180. Technically, we don't really talk about supplementary angles in the context of three things, but we can think of those three as being supplementary in a sense. Similarly, we should be able to tell some information about 1 and 2 being alternate interior angles, and then 4 and 3 being similar. So, put that information together, put those two pieces of information together, and we have 5 plus 4 plus 1 is equal to 5 plus 1 plus 3, 5 plus 2 plus 4 is equal to 5 plus 1 plus 3. That is, 180 is equal to the sum of our interior angles. And from that, we get a great deal of important information, which we're going to start talking about with an example, where here we are given a triangle and we're asked to use that triangle to determine the missing angle measure. So we got that triangle floating around in space. We want to find out what the last side length would be. So for this, we can say that based on that defining property from Euclid's theorem, 180 degrees is equal to the sum of the angle measures, the measure of angle A plus the measure of angle B plus the measure of angle C, where here we're noting the angles in vertex form. Again, that was one of the things we talked about in the last section. We're going to see it this way a lot, but it doesn't make a huge amount of difference how we decide to notate our angles. Anyway, we have those there. We don't know A, but we do know that B is 120 degrees and C is 17 degrees. So, take both of these, push them over to the other side, subtract 120 and 17 from 180, and we will get that the measure of angle A is going to be 43 degrees. Like so.